Hello, my name's Mike Duff, and I'd like to say hello to Amir Iqbal and all the members of the Abdus Salam School for Mathematical Sciences in Lahore. I hope you're enjoying your conference on understanding Abdus Salam. I was fortunate enough to be his PhD student from 1969 to 1972. I was a colleague of his on the faculty at Imperial College, and more recently I was honoured to carry the title of the Abdus Salam Professor of Theoretical Physics. The death of Abdus Salam in 1996 was a great loss, not only to his family and the scientific community, it was a loss to all mankind. For he was not only one of the finest physicists of the 20th century, having unified two of the four fundamental forces of nature, but he dedicated his life to the betterment of science and education in the developing world. So although he won the Nobel Prize for Physics, I think a Nobel Peace Prize would have been equally appropriate. Salam was born in Jang, in what is now Pakistan, in 1926, and came from what he himself described as humble beginnings. In fact, "I am a humble man" was something of a catchphrase for Salam, and used whenever anyone tried to make physics explanations more complicated than necessary. He attended the Government College in Lahore and Punjab University before setting off for England and St. John's College, Cambridge in 1946, where he gained a double first in physics and mathematics. He gained his PhD at the Cavendish Laboratory in 1952, and although he returned to Lahore for a couple of years, he was appointed lecturer in Cambridge in 1954. Undoubtedly, the greatest influence on Salam at these early stages of his career was his mentor at St. John's, the great Paul Dirac, who remained Salam's hero throughout his life, both as a great physicist and as a man who was largely disinterested in material wealth. At the behest of Patrick Blackett, Salam moved to Imperial College London in 1957, where he founded the Theoretical Physics Group. He was elected to a fellowship of the Royal Society in 1959, and he remained at Imperial as Professor of Physics for the rest of his career. And it was there that I was fortunate enough to be his PhD student. In 1964, he established the International Centre for Theoretical Physics in Trieste, which now bears his name, and where he remained until recently, until his death, as its director. Among Salam's early achievements was the role played by renormalization in quantum field theory, when in particular he amazed his Cambridge contemporaries with the resolution of the notoriously thorny problem of overlapping divergences. His brilliance then burst on the scene once more when he proposed the famous hypothesis that all neutrinos are left-handed, a hypothesis which inevitably called for a violation of parity in the weak interactions. He was always fond of recalling his visit to the formidable Wolfgang Pauli, where he submitted, or should I say humbly submitted, his two-component neutrino idea, while Pauli sent him packing unceremoniously and said, "Young man, you don't realise the sanctity of parity." So Salam delayed publication until after Li and Yang had conferred the mantle of respectability on parity violation. That taught Salam a valuable lesson, and he would constantly advise his students never to listen to grand old men. I hope this student at least has lived up to that advice. It also taught him to adopt a policy of publish or perish, and his scientific output was prodigious, with over 300 publications. Of course, the work that won him the 1979 Nobel Prize, that he shared with Glasgow and Weinberg, was for the electroweak unification, which combined several of his abiding interests: renormalizability, non-abelian gauge theories, and chirality. His earlier work in 1960 with Goldstone and Weinberg on spontaneous symmetry breaking, and his work with John Ward in the mid-1960s on the weak interactions was no doubt also influential. One of my greatest regrets is that as a student in the theory group at Imperial from 69 to 72, a group that included not only Abdus Salam but also Tom Kibble, co-discoverer of the theory of spontaneous symmetry breaking and the Higgs boson, no one suggested that weak interactions would be an interesting topic of research. In fact, I didn't learn about spontaneous symmetry breaking until after I got my PhD. The reason, of course, is that neither Weinberg nor Salam nor anybody else fully realized the importance of their model until de Hooft proved its renormalizability in 1972, until the discovery of neutral currents at CERN. Indeed, the Nobel Committee was uncharacteristically prescient in awarding the prize to Glashow, Weinberg and Salam in 1979 because the W and Z bosons were not discovered experimentally at CERN until 1982. Together with Paty, Salam went on to propose that the strong nuclear force might also be included in this unification. Among the predictions of this grand unified theory are magnetic monopoles and proton decay, phenomena which are still under intense theoretical and experimental investigation. More recently, it was Salam, together with his lifelong collaborator John Straththee, who first proposed the idea of superspace, a space with both commuting and anti-commuting coordinates, which underlies all of present-day research on supersymmetry. However, it's to Abdus Salam that I owe the tremendous debt as the man who first kindled my interest in the quantum theory of gravity, a subject which at the time was pursued only by mad dogs and Englishmen. My thesis title, Problems in the Classical and Quantum Theories of Gravitation, was greeted with hoots of derision when I announced it at the Carges Summer School en route to my first postdoc in Trieste. The work originated with a bet between Abdus Salam and Hermann Bondi about whether you could generate the Schwarzschild solution using Feynman diagrams. Well, you can, and I did, but I never found out if Bondi ever paid up. It was inevitable that Salam would not rest until the force and most enigmatic force of gravity was unified with the other three. Such unification was always Einstein's dream, and it remained the most challenging task of modern theoretical physics, and one which attracts the most able and active researchers. I should mention that being a student of someone so bursting with new ideas as Salam was something of a mixed blessing. He would allocate a research problem and then disappear on his travels for weeks at a time. Consequently, it was to Chris Isham that I would turn for practical help with my PhD thesis. On his return, Salam would ask you what you were working on. When you began to explain your meagre progress, he would usually say, "No, that's all old hat. What you should be working on is this," and he'd then allocate a completely new problem. I think it was Hans Bethe who said that there are two kinds of genius. The first group, to which I would say someone like Steven Weinberg belongs, for example, produce results of such devastating logic and clarity that they leave you feeling that you could have done that too, if only you were smart enough. The second kind are the magicians, whose sources of inspiration are completely baffling. Salam, I believe, belonged to this magic circle, and there was always an element of Eastern mysticism in his ideas that left you wondering how to fathom his genius. Thank you. Bye-bye.